While she's getting that set up, the TurboTalk topic, and this year I've tried to go with a no-slide approach for all my presentations, but because this is somewhat of a new topic, I put together 4, so I apologize in advance. Just by raise of hands, how many are working on or are familiar with AI and machine learning systems and infrastructure? 1, awesome. So you all know how to program AIs and you're ready to go, right? What I wanted to talk about, and this is something that's come up as we at Intel have been investing heavily in this space and deploying these kinds of systems, is looking at the change in how we look at securing systems and data when it comes to AI. There's a lot of black boxes involved. There's more than one system. It's not just the cloud. And so really it's about looking at the assets and the components and the different parts of the data and that whole life cycle. And what I proposed in the fall internally and then started talking about was this notion of an AI or data lifecycle with AI. And then what does that mean from a security perspective? And so I don't think I need to convince anyone that AI is happening. And again, AI is a buzzword. It's AI, it's machine learning, it's deep learning, cognitive, neuromorphic. It's all those things. But it's actually changing all of the industries. So we're seeing it adopted in autonomy. We're seeing it adopted in online with search and with advertising, in medical field and genetics. It's being used everywhere. So this slide is just a marketing slide that says it's everywhere. Well, what I want to focus on is how this stuff is getting deployed and how it's being used. And then when we need to understand how we're going to secure this, because there's interesting nuance in that. So this is a logical view, but this is actually taken from some real-world examples that have been deployed. And what's involved in AI is, and machine learning, again, I'm going to use AI to cover the full gamut, just for ease of instead of saying 12 topics, is you have this notion of training, which is where you sort of learn about what you're looking for or what you want to do. You train on known data sets. To create a model, you use various different algorithms and different matching techniques in order to get there, to get to a model that you then can deploy into a live environment, whether that be a camera for object recognition or natural language processing or sentiment analysis. And that's where you get your inferencing. So you're basically trying to understand what is the real world around me and be able to identify that is Toby, that is a male, that is a chair, or that I'm speaking English, or that I like to buy anime. Those are the kinds of things you do with inference. You take your model and you apply it to real world data. And whether it's something like surveillance use cases or autonomy, being able to tell that's a tree or that's a shadow or that's a person I shouldn't hit, making decisions. Then you have, the inferencing can either be real time, like I'm going to make a decision, or it's part of a broader system where you're doing the analytics and trying to combine that with other data feeds or other inferencings across multiple sensors to get to some knowledge. It's here that we're also seeing the application of deep learning and cognitive approaches to really give you that context. So not just I identified a chair, but I understand that the chair is empty in a room that should have people fill, like that context around why I saw what I saw. And that's an important distinction because a lot of people think, oh, the AI is, I found a tree, I know it's a tree. But that doesn't tell you that much. It's really where a lot of the interest right now is about giving me that context, understanding the environment, what's going on, what some people call the unknowns and the unknown things that are around that actually gives you the knowledge that you want to do. And then, of course, you have the results, the outcomes, whether it be a nice pretty pie chart that we're seeing lots of people buy anime this week, or turn left so you don't hit the tree. Those are the actions of the database. And that's a logical view. This can all happen inside your car, or it can happen across a large data center with cloud services and cameras out deployed in the field to satellites. So this is the basic model that, and again, it's a logical view, but this is sort of the bare bones basics of how this stuff comes together. Now, for those that aren't familiar, I've prepared a nice little story about why context is important, but I think for the interest of time, I'm going to skip that unless you want to see how this stuff actually works from going from knowledge, from sort of data that you gather to knowledge to actual context. Is that something of interest to folks? Not? Yes? Raise hands? Yes? Okay, we'll do it quickly. So the question was, and I posed this when I was trying to talk to some security people about AI, or what this all meant, was you have your problem. You're hearing noises on your roof. So of course, as any good technical geek, you're going to put together an AI system and try to figure out what's going on. And so what you do is you start off by training, let's get this going, training a bunch of models against identifying various kind of things you could have on your roof: cat pictures, bird pictures, dogs, rodents, all sorts of different things. And you hook up a live feed camera on your roof, and you get the live feed, and it identifies the stuff. It says you have a cat this time of day, you're getting birds at this time of day, and you're getting a rat around every once in a while this time of day. And so you do the live feed, and it does the object recognition. And at this point, a lot of people think that you're done. And a lot of systems, when you look at it, they say, oh, I'm done. I know I have cats, ravens, and rats. And I put that together with the time series data, and I know that I have a cat problem because every day from 1 to 4 p.m. I see a cat. And you'd be done. Well, that's not actually reality. And this is where things like cognitive and some of the deep learning networks go back and look at that information and other source feeds and actually look to try to figure out what is the strong and weak signals here. And so you do that to provide the context. And now suddenly you're seeing that you're actually not just identifying a cat, but you're looking at his posture and what he's doing, and you see the cat is eating at those time frames. And so now that raises the weak signal to a strong signal, and you know you have a cat eating a rat. And so the reality is you don't have a cat problem, you have a rat problem. Okay? Like I said, a simple example, but it lets you understand sort of how this all flows. That it's not a, oh, I saw a tree. It's, I saw a tree in a certain context. I saw a person in a certain context. So you have to get that deep learning. And that's where a lot of the research today is really focusing on, is on that deep learning cognitive approaches to be able to get you that unknown information that it's not just about automating what a human can do. We can look at a picture and know it's a tree, know it's a chair, but it's telling us something we don't know, and that's where the interest is. So that's the sort of the education part. Okay, great. We know how AI works. We know there's some logical components. But the other thing to keep in mind is that there's different systems involved here. You have training systems on known data that are creating a model with some algorithms. You're deploying that into an inferencing system, whether it be a live feed or it's looking at the whole cloud or looking at Amazon's buying patterns. You have analytic systems doing data fusion across multiple data sets, across multiple systems. And then you have these black box AIs going off and learning stuff about things, and then applying that back to sort of strengthen or weaken signals. There have been already some papers published about attacks, about if I know your algorithm and I know the training set, there are things I can do to some of your live feeds to trick the AI. Some of the best examples were ones of being able to do some slight perturbing on a stop sign. Suddenly the AI can't see a stop sign. Or being able to inject something into the training set so that it will miss. One of the scary things people are worried about in the facial recognition is that there are things you could do to the training set or to your face, knowing the training set, so that you can slip past surveillance cameras. So there have already been some really cool papers on how that, attacking different parts of the model. But then we're also seeing things of you just having incomplete data sets. You know, there have been some crashes lately in the autonomy space. One of them was they didn't train on a fire engine that wasn't red. And so it didn't recognize the fire engine as something that I should avoid because they had trained on red fire engines, you know, cars and everything else. And this town had, I don't know, it was a yellow or something like that fire engine, and so it hit it. So even slight errors in your training set, much worse if it was actually intentional. So the purpose of my talk really is to get to this. And again, I can't solve the problem today. We need the community. And the idea is to sort of identify all the different parts of the puzzle that we have to think differently about. The training infrastructure itself is a lot of times big iron data centers or clouds that are running these processes that are consuming large training data sets to create a model. To say, this is what a car should look like, this is what a cat should look like, create the features, extract those, and put those into a simplistic model that then can be deployed in the real world. And so that infrastructure, if you taint the training set, or you taint the infrastructure upon which the training set is running, you can skew the model that's created. The model then is taken from that training set and then deployed into the real world. And so if I've done a training on a model and I want to deploy it and someone else has done a training on a model and they don't want me to see something, so being able to, how do I know that I'm using the right model? You think that there's security primitives that we should be using, but they're not being used. Like, well, sign the model. Great. How many of your cameras have this signature verification of the model load? None. So this is, again, thinking about the kinds of things that we need to require for some of these decision making. Just telling you whether or not Amazon's, whether or not your buying patterns are, that's important to Amazon, but it's not going to, change somebody's life. Having a car miss a yellow fire truck is an important thing. Genetic research about being able to cure cancer, if it misses something so that some other company or somebody keeps that information longer, that could have an effect on lives. The inferencing systems themselves, this is a real pain point, and if you've gone to any IoT talk, this is what the problem is. You're making decisions based on consuming real-time data on a platform that's $20 even if it's $1,000, but it's a platform, it's an embedded system, it's a low cost relative to what it's doing, consuming those feeds, storing the model, and giving you an action or an output. And they're oftentimes deployed out in the field. So they're out on the side of a building, they're in your car, they're out exposed to tamper and attack. The streams itself, and this is one of the things that one of the attacks, research papers, and DARPA has done some research as well, is taking the live data feed and being able to inject, doing things with lasers and other light sources to skew what the surveillance camera is seeing can actually skew the recognition. And so physical attacks against those sensors, EM attacks and the likes can affect the outcomes. The analytic models, big data analytics and all that, again, inserting either corrupt data or wrong data into the feed can skew the results, can reduce, and oftentimes all it takes is to say something, either to not make a weak signal strong or vice versa, can ultimately change the results. And then, of course, the outcomes and actions. So when you make a decision, turn left, obviously you want to make sure that you are, in fact, turning left. And so the purpose of this quick turbo talk is really to sort of start people thinking about the different parts of the puzzle, and that we need to look at this as an end-to-end approach. We can't just say, well, I've got good encryption on all my network traffic, so we're good. I've secured the data in my data lake or my data set. It's all those pieces working in concert, and an exposure at any one of them can have strong ramifications. And the real reason is, and we've heard the talks, when these AIs are active, in many cases we have no idea how it got from point A to recognition. We know there was a model, we know there's this data feed, but how did it know that it's Toby? And I'm picking on Toby today. We don't know many times. We just know, and the amount of work to go back and try to forensically figure out how it got there is often impossible or too time consuming. And so we as an industry are starting to rely heavily on unknown outcomes. And that means any perturbation of that outcome, anything that's injected in, can have ramifications that we have no idea that it happened. So we have to secure the foundation upon which we're building this. And so my challenge to you, and I'm hoping this starts people thinking, and then maybe next year we can have a deeper discussion on, is looking at how can we provide some common capabilities around securing these AI machine learning kinds of systems, knowing that we can't go in and inspect the code or inspect the outcomes and do forensics on how it got to its decision. And so the point of this turbo talk is to get people thinking. And again, to think about what would be ways we as an industry could come together. Because the one other thing with that picture is there are about 400 companies involved. It's not Intel, it's not Dell, it's not a camera provider, it's all of the above, and the folks doing the work that have to work in concert for this to be secure. So thank you, and again, it's really just to try to get people's brains thinking about some of the problems here, and I'm around all week if you want to talk more about this. This is an exciting new area. Thank you.
Questions?
Okay, thank you.
We actually have an effort underway to document all our algorithms.
Good.
Which is a non-trivial task.
It is a non-trivial.